We are going to need two packages. One is EBimage and the second one is Keras. Keras package uses TensorFlow as a backend. So I'm going to run these two. If you have not installed these two packages, you'll have to first install them, and then once you run the library, they'll be ready to use. For images, we'll get two different types of images. One for planes. So if I type plane and go to images, you'll see there are so many different images that we have. And once you right click on any image, and then you can save that image with whatever name you choose. So what I'm going to do is I'm going to save 6 aeroplane images, and similarly I'll get some pictures of cars and save 6 different cars. So I have saved 6 images of planes as p1.jpg, p2.jpg up to p6.jpg. And similarly, I have saved 6 images of cars as c1.jpg, c2, and then up to c6.jpg. I have created a folder actually and saved all these images there. So if you want to get the path or where this file is, you can right click, and if you go to get info, it will tell you where this file is located. So I can copy location of this file. So it looks like this. This is the location of the file on my computer. So obviously on your computer you will have a different location. So we'll set this as a working directory. Set WD for working directory, and we can copy this there. I'm going to get rid of this. So we are setting our working directory to this directory so that we can read the files easily. Let's run this. So note that this images directory has 12 files. So I'm going to create pics, and let me save all the names there. So we have p1.jpg, p2, and then I'm going to hit enter and go to the next line for car images or pictures. So by running this, we are going to save all these 12 names in pics, and we are going to use this for reading the files. I'm going to create my pic, and initially it will be an empty list. In order to read these 12 files with just one line of code, we can create a for loop. So let's say for I in 1 to 12, because we have 12 files, and then we can provide the expression as my pic that we had earlier, and then we can specify the list item by putting 2 square brackets, and within that I. So pictures will be saved in my pic from 1 to 12, and we'll be reading image. So this read image is part of EBimage package that we had started with, and the names of the files are in pics. So we can say pics I. So pics 1 will be the first one, pics 2 will be the second one, and so on. So we can run this. So those 12 pictures are now read into R. So let's explore what we have. We can make use of print, and you can specify my pic, and let's say we want to look at the first one. So dimensions indicate that it is 281 by 180 by 3, and some sample values are given here. We can also display. So you can see this is an image of aeroplane. This is the first picture. So this is p1.jpg. Similarly, if you look at, let's say, 8th one, so that's a car. So note that first 6 pictures are planes and next 6 are cars. We can also do summary. So you can see values lie between 0 and 1 maximum, and the average value is 0.98. So basically this picture has been converted into numbers that we can use for making classification or prediction. We can also create a histogram. So let's do it for the last picture, which is a car. So intensity lies between 0 and 1, and we have data points plotted in green, blue and red colors. We can do it for the second image. So histogram is going to be slightly different. If you look at the structure of this mypic, which is a list of these 12 items. So it lists everything, like starting from the first one, and it is 281 by 180 by 3. And second picture is 272 by 185 by 3, and so on. One thing you may notice is because pictures come with different sizes, these numbers could be different. So what we can do is we can resize all these pictures to have same dimensions. So because we have 12 pictures, instead of doing this one by one, we'll make use of for loop again. So I in 1 to 12. So this is the format for using for loop. I can say mypic and double square brackets. Within that I can put I, and then we use this resize mypic. So it will take each of the pictures like mypic 1, 2 up to 12, and then let's convert this into 28 by 28. So 28 by 28 is smaller than all these dimensions that we see in the original file. So we can run this. So now if you run this str or structure of mypic, you will notice that now everything has same dimension. 28 by 28 by 3, 28 by 28 by 3. Next, to prepare this data that we have for all the pictures for the training purpose, we will convert them into matrices by reshaping this 28 by 28 by 3 into a single dimension of 28 by 28 by 3. So basically we'll have a single vector of dimension 2, 3, 5, 2. So we'll use a for loop again, and then we save within mypic, and we are going to use array underscore reshape, and this is from Keras package, and we can provide the information. We have 28, 28 and 3. So once you run structure of mypic, you can notice change in the structure. So for all 12 items, now we have a different structure compared to what we had earlier. So one thing to notice here is that we still have 12 different items in this list. So we want to combine this data into one using row bind. Let's create the data that we'll use for training, and we'll call this as train and then x for independent variables, and we'll use y for dependent variable. To start with, I'm going to put null here, so this will be empty, and we'll do this row binding using the for loop. So for training, we'll use first 5 images of planes, and 6th one we are going to use for testing. Similarly, we'll use first 5 images of cars, and 6th car we'll use for testing. So in train x that we created, we'll save rbind train x, which will be empty initially, and then it will keep on adding mypic data for the ith picture. So I goes from 1 to 5. So first 5 pictures of planes will be stored in train x. Now if you want to look at structure of train x, you can see now we have 5 rows. So 1 row for each picture, and then 2, 3, 5, 2 columns. To this we'll combine another 5 for car data. So I'll skip 6th one, which will go into testing. So I'll put 7 up to 11. And 12th one again goes to test. So now if you look at train X, you can see we have 10 rows and we have 2352 columns. So we can create test X, X again for independent variable, and we can have data from my pick 6th one that we did not use in the previous line, and we can combine this with my pick 12th one. This is for plane and this is for the car. Similarly for train and Y for dependent variable or response variable. So let's say a plane is represented by number 0 and car is represented by number 1. Because in train X, first 5 pictures are for plane and we are going to represent plane by 0. So I'm going to put 0 5 times. Similarly, in train X, next 5 pictures are of car and we are going to represent car by 1. So I'm going to put 1 5 times. So this will be the response or Y variable. Similarly, in test Y, we have only 2 pictures, 6th one and 12th one. 6th picture is for a plane, so response is 0, and 12th one is car, so that one is 1. So we can run these 2 lines. Let's use train labels and we'll do to_ categorical, and this will help us in doing one hot encoding. So we'll make use of train Y. We can repeat this with test. So we can run these 2 lines. So you'll notice that when we run this, it uses TensorFlow as a backend. So if you run this, you can see it has created 2 dummy variables. So first one, whenever it indicates 1, that means that's the first class. That means it's a plane. And then for the second column, when we have 1, so that represents, it belongs to the second category, which is a car. So let's create the model. So we are going to use Keras _ model _ sequential. And then we also do few more things. We are going to use this pipe operator, percentage greater than percentage. Basically it takes whatever you have on the left side and passes that on to the next item or line that we have. So we are going to define layer _ dense. So we are going to use fully connected neural network. We can specify number of units in the hidden layer or number of neurons in the hidden layer. So let's go for 256. So this can always be changed to see what impact it has on the outcome. And activation function, we are going to use the most popular one, RELU, input _ shape. So we have to specify how many units or neurons are there in the input layer. So remember we had 2 3 5 2. If you run structure of train X again, you can see that we have 2 3 5 2. So that's what I'm using here. And then we can add another hidden layer using similar process. So in the second hidden layer, let's go for 128 neurons, and our activation function is still the same. And then we connect this to the output layer where we have units. So our output has only 2 values, 0 and 1. So 0 for plane, 1 for car. So I'm going to say 2. And we'll use the most commonly used activation function, softmax. So this is going to be the structure of the model. Let's run this. If you want to look at the summary, you can do summary model. In the first hidden layer, there are 6, 0, 2, 3, 6, 8 parameters. So remember that input layer has 2, 3, 5, 2 units or neurons that we have specified. So 2352 times 256, and to this you can add 256 for the constant. So we have plus 256. Total number of parameters based on first hidden layer is 602,368. Second hidden layer has 128 neurons. So basically 128 times 256 is 32768, and then you add 128 constants to get 32896. And similarly in the output layer you have 128 times 2, 256, and then plus 2, 258. So total comes to 635522. So now we can compile the model by specifying, for loss we are going to use binary underscore cross entropy. So we are using binary because our response variable has only two values. So for optimizer we are going to use optimizer underscore RMS prop, and for metrics we'll use accuracy. So we can run this now. So we'll store this in history. So we'll make use of model that we have specified and connect this to fit. So we are going to use train X for supplying the independent variables for the 10 pictures, and train labels that we created after one hot encoding for the training related response. So we are going to use that. So number of epochs or iterations, let's have 30. So batch size, let's have 32. And for validation split, let's go for 20%. So 20% of the data will be used for validation and 80% of the data will be used for training. So let's run this. So this is quite quick. It doesn't take much time. We have only 10 pictures to train, and if we had like thousands it might have taken more time, but this is a small example just to go through the entire step in a very simple way. And sometimes when you are fitting the model and if you are not getting good results, you may have to rerun all the steps starting from the model. If you look at the picture here, the top one is for loss, and blue line is calculation based on the training part of the data. And within the training data, remember we had 20% for validation and 80% for training. So this is that 80% part, this blue line. And green line is VAL underscore loss. So this is based on the validation error. So initially there's a lot of ups and downs, and after about 10 or 11 iterations, things stabilize at a lower level for loss and higher level for accuracy. We can also plot history. So in this picture, accuracy is the top one and loss is the bottom picture. So let's do model evaluation. So our model is model, and we can connect this to evaluate. The data that we use for developing the model is train X, and response was in train labels. So the final loss value is 0.24, and this is in the training data, and final accuracy value is 0.9. So 90% of the classifications are correct. And remember, in our training we have only 10 pictures. So what it means is 9 pictures have been identified correctly, and there's one picture that was misclassified. So let's store within PRED model predict underscore classes, and this we are doing for train X. So if you look at PRED, if you run this PRED, these are the values we get. We can also create a confusion matrix by creating this table predicted as PRED that we had in the previous line, and actual we can say train Y. So remember, train Y has just one column with 0 or 1 as a value. So we run this line and we get this confusion matrix. So 5 pictures are of this class, which is for aeroplane, and the model also predicts them to be aeroplane. Similarly, there are 4 pictures that belong to class 1, which is a car, and model also predicts those to be cars. So 5 plus 4, 9 correct predictions out of 10. So that's why accuracy is 90%. There is one misclassification where actually it was a car, but model predicts it to be aeroplane. Let's also calculate probability and store in PROB. So model, and then we pipe this to predict PROBA for probability, and our data is train X. So if you run this probability, you'll get probability values of belonging to the first class, which is a plane, or second class. So let's do column bind, C bind, and print probability that we calculated just now, and let's have predicted as PRED and actual as train Y. So these are the predicted probabilities. First picture has been classified as belonging to category 0, which is for a plane, and actually also it is a plane. So you can see first 9 predictions are correct, but for the last one, model predicts that there is a 90% chance that this picture is for an aeroplane or category 0, but actually it is a car. So I'm going to display my pick 11th item. So this is actually a car, but the model predicts it to be a plane. So loss value is 0.009 and accuracy is 1 or 100%. So please note that in test data we have only 2 pictures, one for a car, another for a plane, and both of them, if they are correctly identified, so accuracy is going to be 1. We can do PRED and then again do model pipe and predict underscore classes, this time with test X. So note that in PRED there are only 2 values. So first picture belongs to category 0, which is a plane, and second one belongs to category 1, which is a car. But if we do the table, so we get this confusion matrix for these 2 items, and both are correctly identified. There are no misclassifications. So we can display my pick. So in our test, remember we had 6th item and it was a plane, and similarly we had 12th item in test data, and 12th picture was for a car, and these 2 are correctly identified.